Good morning students, this is Usha from G.K.Jain High Secondary School. Today we are going to see the topic measurement of basic quantities in 11th standard physics. In this we are going to learn about the measurement of length, mass and time. Let us move on to the topic. Measurement of basic quantities. First we are going to see measurement of length. Length is defined as the distance between any 2 points in space. The SI unit of length is meter, m. Microsm refer large world in which objects and distance are very large. Example, large object like the galaxy, star, sun, earth, moon, etc. It refers to a large world in which both object and distances are large. Object like molecules, atom, proton, neutron, electron, bacteria, etc. and their distances constitute microsm. So microsm refers some world in which objects and distance are small sized. Distance ranging from 10 power minus 5 meter to 10 power 2 meter can be measured by direct method. So here given a tabular column, that is prefix for powers of 10. The multiple, prefix and symbols are given. 10 power 1, it is known as deca, DA. 10 power 2, hecto, H. 10 power 3, kilo, K. 10 power 6, meha, M. 10 power 9, giga, G. 10 power 12, tera, T. 10 power 15, peta, P. 10 power 18, exa, E. 10 power 21, zeta, Z. 10 power 24, iota, Y. The same way in powers of minus 1. So 10 power minus 1, deci, D. 10 power minus 2, centi, C. 10 power minus 3, milli, M. 10 power minus 6, micro, mu. 10 power minus 9, nano, N. 10 power minus 12, pico, P. 10 power minus 15, femto, F. 10 power minus 18, atto, A. 10 power minus 21, zepto, Z. 10 power minus 24, ecto, Y. So next we are going to see how to measure the small distances. So measurement of small distances, first we will see the screw gauge. So you all have learned in 10th standard. Screw gauge is an instrument used for measuring accuracy the dimension of object up to a maximum of about 50 millimeter. The principle of the instrument is the magnification of linear motion using the circular motion of a screw. The least count of the screw gauge is 0.01 millimeter. Next is vernier caliper. Vernier caliper is versatile instrument for measuring the dimension of an object, namely diameter of a hole or a depth of a hole. The least count of the vernier caliper is 0.1 millimeter. Next is measurement of large distances. Triangulation method, parallax method and radar method are used to determine very large distances. First we are going to see triangulation method for the height of an accessible object. Let me explain this diagram first. Let AB is equal to H be the height of the tree or the tower to be measured. Let C be the point of observation at distance x from B. Place a range finder at C and measure the angle of elevation. What is the angle made by them? Angle ACB is equal to theta. From right angle triangle ABC, tan theta is equal to AB divided by BC, opposite by adjacent, which is equal to H by X. So when we take the X to the other side, we will get height H is equal to X tan theta. Knowing the distance X, height can be calculated. So next is parallax method. Very large distances such as the distance of the planet or a star from the Earth can be measured by the parallax method. The apparent change in the position of an object with respect of the background when the object is seen from two different positions, it's called parallax. The distance between two observation points, it's called basis. So here the diagram shown here. So now we can say an observer is specified by the position O. The observer is holding a pen before him against the background of a wall. So when the pen is looked at first by our left eye L and then by our right eye R. So closing the other eye when you are seeing the pencil. The position of the pen changes with respect to the background of the wall. The shift in the position of an object when viewed with two eyes, keeping one eye closed at a time, is known as parallax. The distance between the left eye and the right eye in this case is the basis. Angle LOR is called parallax angle or parallactic angle. So LR as an arc of length B and radius LO equal to RO equal to X, we will get theta is equal to B by X, where B is the basic, X is the unknown distance. Knowing B and measuring theta, we are able to calculate your X value. Next one, parallax method, determination of distance of moon from Earth. So here the diagram is given. In this C is the center of the Earth. AB are two diametrically opposite places on the surface of the Earth. From A and B, the parallax theta 1 and theta 2 respectively of moon M with respect to some distant stars are determined. How we can measure it? With the help of the astronomical telescope. So, the total parallax of the moon suspended on Earth, angle AMB is equal to theta 1 plus theta 2 is equal to theta. If theta is measured in radian, then theta is equal to AB divided by AM. So, you will get AB is equal to AM into theta. So, this also can be written as AB is equal to MC into theta. So, we are able to calculate the distance of the MC of moon from the Earth, which is equal to AB divided by theta. The next method is radar method. The word radar stands for radio detecting and ranging. It is used to measure accurately the distance of the nearby planets such as Mars. In this method, radio waves are sent from transmitter which after reflecting from the planet are detected by the receiver. You can see here the diagram. By measuring the time interval t between the instant the radio waves are sent and received, the distance of the planet can be determined as the speed is equal to distance traveled divided by time taken. So distance d will be equal to speed of the radio waves into time taken. So the formula will become d is equal to v into t by 2, where v is the speed of the radio waves. As the time taken t is for the distance covered during the forward and the backward of the radio waves, it is divided by 2 to get the actual distance of the object. So this method can also used to determine the height at which an aeroplane flies from the ground. So next one is size of the object and distance, that is range and order of length. So distance of boundary of observable universe is 10 power 26. In this way they are given few points, that is few where the distance of the sun from the earth is going to be 10 power 11. Radius of the earth is going to be 10 power 7. So like this we are able to do it. Next is thickness of the paper is 10 power minus 4. Right? Length of the typical virus 10 power minus 8. Diameter of the hydrogen atom 10 power minus 10 meters. Some common practical units. 1 Fermi is equal to 10 power minus 15 meter. 1 angstrom equal to 10 power minus 10 meter, and 1 nanometer is equal to 10 power minus 9 meter. 1 micron is equal to 10 power minus 6 meter. 1 light year is the distance traveled by light in vacuum in 1 year. So 1 light year is equal to 9.467 into 10 power 15 meters. So 1 astronomical unit. The mean distance of the earth from the sun. So 1 AU is equal to 1.496 into 10 power 11 meters. 1 that is parallax seconds. So distance at which an arc of the length 1 astronomical unit subtended at an angle of 1 second of arc. So 1 parsec is equal to 3.08 into 10 power 16 meter, which is equal to 3.26 light year. The next one is Chandrasekhar Limit, CSL, the largest practical unit of mass. So 1 CSL equal to 1.4 times the mass of the sun. The next one is shake. The smallest practical unit of time is shake. 1 shake is equal to 10 power minus 8 seconds. The next topic is measurement of mass. It is the quantity of matter contained in a body and its unit is kilogram, kg. Ordinarily, the mass of an object is determined by using common balance, spring balance, electronic balance, etc. For measuring larger masses, we make use of gravitational method. For measuring small masses, we make use of mass spectrograph. So here the column, the range of masses is given. For electron, the mass is 10 power minus 13. And for proton and neutron, it is 10 power minus 27. Right? So, and for the raindrop, it is going to be 10 power minus 6. And for human, the mass is 10 power 2. Moon is 10 power 23. Milky Way is 10 power 41. So, some of the weightless balance commonly used are common balance, spring balance and electronic balance, which already said to you. Now we are going to see measurement of time interval. So an atomic standard of time is based on the periodic vibration produced in a cesium atom. A clock is used to measure the time interval. Some of the clock developed later are electronic oscillator. The second one is solar clock, quartz clock, atomic clock, decay of elementary particles, radioactive dating, etc. Here the order of time interval also given. So period of X-ray is 10 power minus 19. Period of radio waves is 10 power minus 6. Wink of eye is 10 power minus 1. In the same way, time period of a satellite is 10 power 4. Age of universe is 10 power 17 seconds. Thank you. Yes students, you all have learned about the measurement of length, mass and time. Let me meet you in the next video. Thank you students.